All right, this is lesson 8. Okay, this is lesson 8.6, scientific notation. Make sure you're writing the vocabulary word. Somebody tell me, what is the definition of scientific notation? Not all at once.
I don't know.
It's right there.
Oh, we took this one.
Somebody read it. Come on.
A number is written in scientific notation when it is represented as the product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10.
Yep. All right, so again, the only part of the key idea I need you to write in your journal is this bottom section, because it's kind of the sort of the unwritten rule, I guess it's a written rule that you just need to memorize. If the number is greater than or equal to 10, it has a positive exponent. You see here on the 10 to the 3. So you will move the decimal point to the left. It feels like it's opposite of what it should be. So when you have a whole number, 8,600, like this, the decimal is technically after the 0, right? To turn it into scientific notation, you move to the left until you only have one number in front of the 0, or in front of the decimal. So then this becomes 8.6, and then you have 3 place values that you had moved the decimal, so that becomes your exponent.
I kind of get it.
Uh-huh.
Seems a lot easier than it looks.
It is really easy. It's literally just remember left or right. If you are dealing with a less than a whole number, so for instance, 0.0024, we are going to move the decimal to the right until there's only one number in front of the decimal. So again, we moved it 3 place values, but since we went to the right, the exponent is a -3. So a real quick rule of thumb is if you see a positive exponent, you know it's a whole number, greater than 1, whole number. If it's a negative exponent, you know it's less than 1. It's a decimal.
That's gonna be it. That one's gonna confuse.
It just takes practice. You'll get it. All right, so let's look at example 1. We're going to write 173 million in scientific notation. So the first thing we do when you're writing notes is write the big number. And then we are going to go until we only have one number in front of the decimal. So you're going to count.
8.
And move it 8 places to the left. So then you're going to write 1.73, because those are numbers, times 10 to the however many decimal places we moved.
Oh, wait, in front of the decimal is to the left. Wait.
I don't know what you're asking.
He said until we only have one number in front of the decimal.
Right, so the 1 is in front of the decimal, everything's behind the decimal.
Oh, it's behind. I thought that was in front.
No, in front is the 1.
We're in America. We read left to right.
Correct. So the 1 is in front of the decimal, the 7 and 3 is behind the decimal. And you don't have to include all the zeros. All right, now let's write 0.0000032 in scientific notation. So again, we're going to move the decimal to where?
The right.
Yep, until when?
One number.
There's 6 zeros?
Yeah, what number? Tell me what number.
3.2.
So we're going to put it between the 3 and the 2.
How many zeros are there?
6. Well, there's 5 zeros plus the 3. So you're moving it 6 places.
Times 10 to the power of -6.
Correct. So 3.2 times 10 to the power of -6.
Okay, that.
All right.
Mm-hmm.
Any questions? All right. Go do numbers 1 through 6 on the triads.
You have to write this down.
9%.
All right. So now we're going to take the scientific notation form and switch it back to standard form, which is what numbers are normally in. So if I have 3.22 times 10 to the -4, how am I switching it back into standard form? Which way am I going to move the decimal?
To the left.
to the left. So from the 3, you're going to go back 4 spaces.
The 0.000.0.0000.
Nope, just 3, because the 3 counts as one of your place values. So just 3 zeros in front of the 3. And yes, to make it proper, you do need a 0 in front of the decimal. You can't just put 0.00322. That would not be correct. All right, for B, we have 7.9 times 10 to the 5th. So which way am I going to move the 0?
To the right.
To the right.
1, 2, 3. So 790,000.
Correct. 790,000.
6, 7.
I don't like scientific notation.
Why?
No, so we're
It's
going to-
literally remember whether you're going left or right. And
But
then,
I don't know why it's even like why people do it. Why can't you just straight to them?
so you don't have to write numbers that have 15 zeros in them.
6, 7.
I'm not always right.
I know.
I'm just often right. All right, do numbers 7 through 9 and 10 through 16.
That's then.
Yep, you'll be fine. Does everybody have this?
I did not miss that.
All right, a dog has 100 female fleas. What is the total amount of blood consumed by the fleas each day?
This is
Why do we
disgusting.
have to
Gross.
talk about this?
Well, because this flea is magnified,
We need to-
it tells you the female flea consumes 1.4 times 10 to the negative 5th liter of blood each day. So how many fleas consume this much blood? 1. So we're going to convert this to standard form, and then we're going to multiply it times how many fleas are on this dog, right?
Oh my gosh.
Okay, so how many decimal places are we moving?
5.
5.
0.000.
To the left, thank you. And then we need to multiply that times 100.
Which is 0.0014.
So it really just shifts your decimal 2 to the right because it's got 2 zeros and 100. So then how much blood does 100 fleas consume?
0.0014 liters per day.
Correct. You can also, we got to change it to, because this is
Shouldn't it
in
just be 1.4?
liters.
No, it'd be
1.4.
It'd be 14. 14
No, you had it right, 1.4.
Oh.
10.
So we're going to multiply it times 1,000 milliliters to change it to milliliters. So 100 female fleas drink 1.4 milliliters
That's
of
actually
blood
not a lot.
each day.
That's not that much. I feel.
It's not.
For 100 fleas?
Still, it's gonna itch.
Yeah. And then if they do it every day for 100 days,
Oh no. This is really nasty.
gross.
Why would we need to know the
The math?
the flea thing?
I don't know. It was just somebody thought, they probably thought, oh, this will gross them out. All right. Do your last few self-assessments. And that's it.